Jai Hind to all of you. I am Dr. Ritish Kumar. I am going to give a lecture on the topic of pre-emphasis and de-emphasis in the communication engineering subject. This is the lecture number 3. So, in this topic, first we need to understand what is the pre-emphasis and de-emphasis. So, before going to start this topic, first we need to see what is the syllabus of the university syllabus. So this is the university syllabus where the pre-emphasis and de-emphasis lies in the unit number 3. This one. This one. So here we will cover the topic of pre-emphasis and de-emphasis of the unit number 3. And for this we have these are the recommended books which we have mentioned here. So preferably I will recommend the book number 1, Simon Hacken and Torrent Schilling, the book number 3. As you can see here, communication system written by the Simon Hacken and the Torrent Schilling, principle of communication system. So these topics you may find in these 2 books, so you can refer these books as well. Next. So let's begin with the topic. So pre-emphasis. Pre-emphasis. Right. So what is the pre-emphasis? So as name suggests, pre-emphasis, that means it emphasizes the signal before transmitting through the channel. So pre-emphasis means to amplify the signal strength before the modulation process, we can say here. Now, why we need the pre-emphasis in the modulation process? So, if we talk about the audio signal, the audio signal PSD, that is the power spectral density that we have in the case of like in this way. Right, this is a frequency spectrum, and this one is a PSD, power spectral density of the audio signal. You can see audio signal or voice signal as well. So you can see here, this is a peak value here. Now, this is the signal strength that we have for the audio signal, that is called the power spectral density, and at a particular frequency, we can say at this point, this is the boundary condition I assume here, that is F1, and this is the boundary condition beyond which the frequency will be considered as a higher frequency. Below this frequency, the frequency will be considered as a lower frequency range. Now, what will be the effect on the SNR if we send this, if we transmit this signal through a channel? So, what will be the effect of what will be the effect of noise over this PSD? So, ideally, we can say the PSD of white noise we have. Suppose the power spectral density, ideal power spectral density of noise, two-sided PSD of the white noise is N naught by 2, that we have read in this is the frequency, and this one is the power spectral density of white noise, right? So if I correlate the things, if I say what will be the SNR at this frequency range, beyond this frequency range and below this frequency range. So this PSD of power spectral density of noise is in the ideal case, we can see in the ideal case. So you can see throughout the frequency range, the PSD of white noise is constant by nature, and it has the value of N naught by 2, right? So if I say this is a boundary condition of low frequency and high frequency, right? If I talk about the SNR, right? SNR is the signal to noise ratio. That means signal power. It is a ratio of signal power to the noise power. If I say at this lower frequency range, the strength of the signal is high, while the noise has the nature of constant by nature, and beyond this frequency, F1 frequency, the signal strength goes on decreasing, while the noise PSG remains constant beyond this frequency. So we can say at this frequency below, we can say below f1, the signal strength increase, and above f1 the signal strength decrease. So we can say if signal strength increase, then SNR, uh, we can say the SNR is greater than 1, while for the case of above f1, the SNR would become less than 1. So we can say the SNR is getting improved at this low frequency range. SNR is less than 1 at high frequency range. So this is the case. So at last, what should be the SNR for having the better communication? We can say the SNR should be as high as possible, because we need to have signal strength as high as possible, while the noise strength as low as possible, so that we can achieve the high SNR at the receiver side. So this is the condition to have a better communication between transmitter to receiver. So this is the case of white either white noise PSD. If I talk about uh, if I talk about the actual PSD of the noise, right? So what should be the nature of the noise? So actual nature of the noise should be like in this form. That means at the higher frequency, the noise effect will be more, but at lower frequency range, the noise effect will be less as compared to the higher frequency. So you can also, this is the practical nature of noise, right? So this is a practical nature of noise. As you can see, this is a at low frequency the value, it has the minimum value, but at higher frequency it has the value is goes on increasing as the frequency goes on increasing. This is the nature of practical noise. So if I correlate the things with this practical noise with this power spectral density of the audio signal, this is power spectral density of the noise, right? So you can see here the signal strength is more, while the noise strength is weak, comparable. So you can see here signal to noise, if signal strength more and noise goes on decreasing, then we have a signal to noise ratio is greater than 1, right? While beyond this frequency range f1, the noise is getting increased, while the signal strength is getting noise strength is getting increased, while the signal strength is getting decreased. So we can say signal strength is getting decreased while the noise strength is getting increased. So in that case, the signal to noise ratio is less than 1. So in, to have the better communication, we have the signal to noise ratio as high as possible. So this condition should be satisfied beyond the frequency of this f1. So we can say at the higher frequency side, we need to improve the signal strength, because to have the better SNR at the receiver side. This is the main cause to emphasize or to amplify the signal at the transmitter side before the modulation process, so that we can have the improved SNR at the receiver side. So this is the main logic to have the pre-emphasis before the modulation process. Now, what should be the circuitry to have this pre-emphasis? Now, let's begin with the circuitry. So, actually, the signal is the PSD of the signal is looking. Sorry. Actually, the signal strength is looking. Just wait. Okay. Actually, signal strength is looking like PSG is looking like this way, right? As we have discussed earlier. So I presume that some kind of system we have, some kind of circuitry we have that is known as pre-emphasis circuit. Your system, right? Right. So I presume that this is the frequency at which this is the boundary condition of frequency. Beyond this frequency, the frequency is considered as a high frequency. Below this frequency, the frequency is considered as a low frequency. Right. So this is one is the positive side, and similarly we have this one is the at the negative side as well. So this one is the 0 we can treat here, right? So what kind of the system has the frequency response so that we have a improvement the signal strength at this frequency above the frequency is f1. So the signal the impulse response should be looking like in this way. Up to f1 it should be in the constant by nature. Hf we can see, right? Beyond the frequency f1, the system impulse ratio should go on increasing. Similarly, we have up to the frequency of -1, minus f1, right? Beyond this frequency, it goes on again increasing. So this should be the impulse response of the pre-emphasis circuit. If I pass this signal through this frequency response through this system which has a frequency response like in this way. So after passing this signal through this system, we have the signal in this pattern, like you can clearly see here up to, right. So I presume that this one is the f1, this one is the minus f1, right? As you can clearly see here, minus f1 to f1, it has a constant by nature. It has the some constant value. So we can say here this pattern should be as same as the input signal. So this one is the in similar train, right? Above this frequency, the signal strength goes on decreasing, right? Similarly, but this system response hasn't have the nature of increasing having the nature of increasing. So this strength is getting improved beyond this frequency because of the system having the linearly increment beyond this frequency. So we can say there is a little bit improvement in the improvement up to this point, a highest improvement beyond which is very far away from the frequency f1. So you can see here this is the length of this arrow is low, the length of arrow is getting increased, again getting increased. Similarly, we have for the case of this frequency range, uh, length is getting increased as we move away from the frequency, right? Similarly, so the change is looking like in this way. So after passing this signal through this pre-emphasis logic, we have a output signal in this way. So you can clearly see here, right? In this portion, beyond the high frequency region, the signal strength gets improved from this to this level, right? So, because of this, signal strength is getting improved at the higher frequency, while the noise uh, is remains the same. So we have a good SNR at the receiver side. So this process we will do before the modulation process. So this is the pre-emphasis logic that we need to understand. So what should be the circuitry to have this kind of uh, impulse response here? So this is looking like high pass filter, or we can say it is just like lead compensator as well. So you can treat the you can make the circuit as a lead compensator as well. So this is output, this is gain, C, R, and R2. This is a lead compensator. So this circuit you can use to have this kind of frequency response. After passing this logic through this circuit, we have this kind of signal strength, right? So this is our main aim to have the improved signal strength at a higher frequency. So this is the pre-emphasis logic and pre-emphasis circuit that is just like a lead compensator. So now whatever we have done at the transmitter side, just we have to do the reverse operation at the receiver side. So the circuit that is the reverse operation of the pre-emphasis is the de-emphasis. Whatever we have done at the transmitter side to amplify the signal, do the just do the opposite of it by using a de-emphasis circuit. So it is just like a high pass filter. So in the case of de-emphasis, we will consider as a low pass filter here. So first we need to understand what is the de-emphasis. Now come to the point of de-emphasis. Okay, de-emphasis. De-emphasis always be done after the demodulation process, as in the case of pre-emphasis always be done before the modulation process. Therefore the de-emphasis will always be done after the demodulation process. So de-emphasis circuit, de-emphasis circuit, right? As we earlier discussed about the output of the pre-emphasis circuit looking like, right, looking like in this way. This is the frequency, this is the boundary condition which separate a high frequency and low frequency region, right? So if we pass this logic from this de-emphasis circuit, then we have the actual signal that we have in the transmitter side, the audio signal PSD. So it is just like the actual PSD of the message signal, right? Now we have this kind of trend, right? So what we need to do, we need to decrease this strength up to this level, right? So this should be goes down, this should be goes down, this should be goes down, this should be goes down. Just do the opposite operation that we have in the case of preemphasis. So finally we have this kind of trend of the signal after passing the logic through de-emphasis circuit. So the what kind of the impulse response the de-emphasis circuit it has. So this is the impulse response, right? So up to the frequency f1 or minus f1, it should have the constant by nature, right? Now you want to decrease the strength of this signal from this point to this point. That's why we have to decrease the strength of impulse response of the system, looking like this way. So it looks like a low pass filter, right? So we can say the de-emphasis circuit is nothing but a low pass filter. So you can use the simple low pass filter here. V in, V out, R and C. Simple low pass filter you can use as a de-emphasis circuit, right? So by passing through uh, this logic through this one, we have this kind of trend. This one is actual message PSG. So as we can clearly at last I will conclude this topic. What is the preemphasis and de-emphasis that we have read here? Preemphasis always be done before the modulation process to emphasize the signal strength, to have the better SNR at the receiver side, but while the de-emphasis always be done at after the demodulation process to have the actual signals by decreasing the signal strength. I think these two topics is clear to all of you. Thank you.